All right, sometimes our answers are not as pretty as the 4 examples that we just did. So let's look at some more. So I have x squared is equal to 3. How can I isolate x, aka I want 1x, but now I have 2. So the opposite or the inverse of a square is to take the square root. And if I take the square root of one side, what must I do to the other side? Now I have x squared is the square root of x squared is equal to the square root of 3, which is going to cancel out the square and leave me with x is equal to the square root of 3. Okay, now, is the square root of 3 a perfect square? Absolutely not. There are no two identical numbers that can multiply to give me the square root of 3. But just like all of our other examples, how many solutions did we have? We always had a positive and a negative solution. Nothing changes here. I would still have a positive square root of 3, and a negative square root of 3. So I'm going to still use my Desmos to check my answers to make sure that my solutions are correct, aka where are they touching the x-axis. And so they give me these long behind decimals because the square root of 3 represents a rational or an irrational number. It's irrational because I cannot write it as a fraction. So I'm going to use my calculator to see what the square root of 3 is equivalent to. And what does negative square root of 3 equivalent to? All right, so we're going to look at our solutions, zeros, roots, x-intercepts, and see if the decimals match. And they do. 1.73205, 1.73205, negative 1.73205, negative 1.73205, which means our answers are correct. All right, x squared minus 10 is equal to 18. How can I solve for x? Can I first take the square root of x? Let's look at our previous examples. All of the other examples that we did, the rest of the examples that we did had a parentheses. So we ended up dividing because something was being multiplied, or just straight taking the square root. Can we do that right here? Hopefully you said no, and I should get rid of this minus 10. How can I do that? What is the opposite of subtracting 10? Adding 10. And whatever I do to one side of the equation, I must do to the other side of the equation. Well, what's going to cancel out? What do I bring down? X squared is equal to, what is 18 plus 10? 28. Okay. Now what should I do since I have x squared and I want it to be 1x? What is the opposite of a square? Taking the square root. So if I take the square root of this side, I must take it of this side. Well, the square root is going to cancel out the square, and I will be left with x is equal to, wait a minute, the square root of 28. Now, this is a throwback lesson to simplifying radicals, and I want to know what's the biggest perfect square that can divide evenly into 28. So what are my perfect squares? 1, 4, 9, 16, 25, 36. I should stop right here because I don't want any more bigger numbers. And I want to know which one of these can divide evenly into 28. So 28 divided by 25, 28 divided by 16, 28 divided by 9, 28 divided by 4. That means I can take the square root of 28 and break it up into the square root of 4 and the square root of 7, which will give me 2 square roots of 7. But it will be a positive 2 square roots of 7 or a negative 2 square roots of 7, because the square root of 4 is equal to 2. And so my solutions would be x is, that was ugly. x is equal to a positive 2 square roots of 7, or x is equal to a negative 2 square roots of 7. And when I use my Desmos, they give me these ugly decimals. So I'm going to type mine in to see if it is equivalent. 2 square roots of 7 is equivalent to that, which is the same thing. So that means this solution is correct. Well, what about negative 2 square roots of 7? There we go. It is also correct. All right. X plus 2 squared is equal to 5. I want to isolate x, but I cannot isolate x if it is attached to that plus 2, which is also attached to the parentheses. So I want to get rid of the square. And to get rid of the square, I must take the square root of both sides. That is going to cancel out my square and leave me behind with x plus 2 is equal to a plus or minus square root of 5. Because the square root of 5 is not perfect, and the only perfect squares that I can divide are 1 and 4. Therefore, I just leave it as it is. But my x is not isolated yet because it's being added by 2. And the opposite of adding 2 is to subtract 2. But because I have these two different signs right here, I'm going to split up my equation. Meaning my equation would be x plus 2 is equal to a positive square root of 5, or x plus 2 is equal to a negative square root of 5. And I still need to solve for x just double time. So how do I do that? What is the opposite of adding 2? Subtracting 2. Whatever do to one side, I do to the other side. Now, can you subtract 2 from the square root of 5? Absolutely not, because they are not like terms. So that is going to look something like this. X is equal to negative 2 plus the square root of 5, because I cannot combine them because they ain't like terms. Or x is equal to negative 2 minus the square root of 5, because they are not like terms. So, using Desmos, you check your answers. Obviously, we know they're going to give us ugly decimals. So you would have to type your answer into Desmos as your radical to see if they are equivalent. Boom, that's right. And what about negative 2 minus radical 5? Boom, that's right. So you just got to go a little extra mile. Still can use Desmos, just got to go a little extra step. All right, let's look at our last example. We have 3 times x minus 7 squared plus 16 is equal to 46. What should we do first? Should we divide 3 by everything or subtract the 16? We should subtract 16 first, because I can't divide 3 from here and then from here and then from here. It's just a mess. So I'm going to get rid of this positive 16 by subtracting it from both sides of my equation. Which means I get to bring this down. So I bring down 3 times x minus 7 squared. Well, this is going to cancel out. It's equal to 46 minus 16, which should be, what, 30? All right. Are we done? No, because now I need to get rid of this 3 that is being multiplied to this parentheses, which means we should do what? Divide 3 from both sides of my equation, which means this will cancel out. And I will have x minus 7 squared is equal to 30 divided by 3. Use your calculator if you must, but you should get 10. All right. I still want to isolate x now, but it has this square. It has a parentheses and it has a square. The inverse of a square is to take the square root. Therefore, I must take the square root of both sides. All right. Which is going to give me x minus 7 is equal to a plus or minus square root of 10, because 1, 4, 9, those are some of my perfect squares, and none of them is going to divide evenly into 10 where I can break it up into two factors. So it just stays. My favorite type of problem. We still ain't done though, because x still is not isolated because it's being subtracted by 7. What is the opposite of subtracting by 7? Adding 7. And if I add 7 to one side, I must add it to the other side. Which means this will cancel out, and I would be left with x is equal to 7 plus or minus the square root of 10. Now I can rewrite this as x is equal to 7 plus the square root of 10, or x is equal to 7 minus the square root of 10. Now I'm going to use my Desmos to convert these into some decimal answers so I can check using my graphing calculator. So 7 plus the square root of 10 is equivalent to 10.162277, whatever. Or 7 minus the square root of 10, which is equivalent to 3.837722, on and on and on. Okay. All right. Now I'm going to use my Desmos calculator to check and see if my solutions were correct. I've already typed my equation in, and I want to know where is it touching the x-axis, aka my intercepts, and here they both go. One of them was 3.83772. Well, 3.83772, boom. And then the other one was 10.16228, 10.1622. They just rounded. It's right. So, that's that lesson.